Okay, this is Mr. Peterson, and we're on the Algebra 2 review for Chapter 2, Part A. And we're looking at problems 29 through 36 in this video. What we're supposed to do in this first one here is to factor it, and you'll see that there's a common factor here of 5. That's the greatest common factor, but because of the negative up front, we pull out the negative version of that GCF, so negative 5. Dividing all these by negative 5 gives 12x squared minus 5x plus 3. And now we're going to try to set up a star here to see if we can break that up further. And you put the leading 12 on the wings. Multiplying 12 times positive 3 gives 36. And we need two numbers that multiply to give that 36 and add to give the negative 5 you'll find in the middle of the problem. So I'm going to list the number ways of getting 36. You have 1 and 36, and that doesn't help us because we can't get negative 5 from that pair. 2 times 18, that's not going to help us. 3 times 12, those numbers don't add up to 5 even if you play with the signs. And the next one is 4 times 9. That one has a lot of promise. We are going to cross off 6 times 6 because that's not going to work. So let's see if we can get 4 and 9 to work. Well, if we make them both positive, that gives 36, but it doesn't add up to give a negative 5. The other way to get 36 is using two negatives. Negative 4 times negative 9 gives 36, but they don't add up to negative 5. So if we make one of them negative, that's promising. Those don't add up to 5, though. Negative 5, I mean. And that pair does add up to negative 5, but it doesn't multiply to give 36. So we've exhausted our possibilities here. And we'll put big fat question marks. So the trinomial part of this is prime. However, you don't write prime in this problem because we actually factored it. So you're going to circle the answer that you got earlier. And that's the furthest you can go with this one. Okay, if you look at the next one, there's no GCF, so I'm going to make a little notation that we looked for a GCF, and there's none there. And when we try to get the star going here with the 6 on the wings, 6 times 1 is 6, so we're looking for two numbers that multiply to give 6 and an add to give negative 8. Well, 6 and 1 is one way to multiply to get 6, but you're not going to get 8 out of those numbers even if you play with the signs. 2 times 3 is the only other choice, and that doesn't add up to 8 or negative 8. It doesn't add up to negative 8 no matter how you play with the signs, so we're out of possibilities here. And this one didn't factor either with the greatest common factor or with the star, and that's when you write prime. So this one didn't factor at all. And there we go. Okay. On this next one here, we have a factored expression already, and we're supposed to find out the solutions that work in this. It does say equals 0, and when three numbers multiply to give 0, at least one of them has to be 0. Well, let's try this one, and that's a bust. 8 never does equal 0. If you set this one equal to 0, you can solve and find what x would be. In this case, it's going to be 3/2. Or the last one might be the one that turns out to equal 0, in which case you get negative 7. Now you do have permission to skip this step and go straight to the other answers, if you're reliable with it, okay? Now you can check this answer, by the way, by simply storing the values, negative 7 and 3/2, one at a time. So for instance, 3/2 stored as x, and then if you type all this, it should equal 0. That's how you can check these. All right, example 32 is similar to what you're expected to do. And what you're going to do here is factor out, I believe this one, they all divide by 2. So you're going to pull that 2 out. And then you set up your answer here, or you set up your factored version is what I meant to say. And let's off to the side do a little star work here. There's a 3 on the wings, and I get that from right there. 3 times negative 12 is negative 36. And you get a negative 16 underneath. And let's go through the factors of 36 that might be useful to us. 1 and 36, I don't think we're going to get 16 out of that. 2 and 18, okay, I think we got it here. 2 and 18, if you make the 18 negative, everything works. Now this first side here, 3 over 2, you can just write 3x plus 2. And the other side, when you simplify, becomes 1 over negative 6. So you're going to say 1x minus 6 here. Setting this equal to 0 is a bust. So 2 equals 0. That's not true. But if you set this equal to 0, you get an answer of negative 2/3. You can find that by taking that, pretend that went across the equal sign, and then divide by that number there. So this one here is going to give an answer of 6. And you could check those by plugging them into the original. You would, for instance, store negative 2 divided by 3, stored for x, and then type this expression. And if your answer is 0 on your calculator, you know you've got the right answer down there. And then you simply store the other one to check it. Okay, on this one, we're going to bring this over and put it in standard form to start with. 4x squared minus 21x plus 5 equals 0. And there's no common factor, so I'm going to go directly to the star. There's a 4 on each wing here. And multiplying 4 times 5 gives 20. And we're looking for a negative 21 in the middle. So let me write that. 20 up here and negative 21. Numbers that multiply to be 20 and add to give negative 21 are negative 1 and negative 20. And this side over here simplifies to 1 over negative 5. So we get the factored version here of 4x minus 1 and 1x minus 5 equals 0. Setting this equal to 0 yields x equals 1/4. And setting this equal to 0 gives x equals 5. Okay, the next one here, number 34, we have to distribute to start with. So that gives us 4x squared plus 4x. And I'm going to go ahead and bring the 1 over to join the fray. And this one here is a perfect square trinomial. Maybe you notice that there's a perfect square at the front. That's 2x times 2x. And the back also, that's 1 times 1. And then if you take 2x times 1 and double it, you get the middle. So we're good to go. It's going to be 2 factors. 2x and 2x, 1 and 1. And you borrow the middle sign. And these both yield the same answer. X equals negative 1/2. So there's only one answer to the problem. Negative 1/2. Okay, final 2 on this page here. Let me get rid of a stray mark that showed up there. And what we're supposed to do is find the zeros. And that's really the same exercise. We're trying to find the x values that make the y turn into 0. So you can see I changed the y to 0, and I'll do it again on the other one here. So this is really the same exercise. Okay, so 0 equals, and let's put a 1 on the wings of a little star over here. 1 and 1. 1 times negative 3 is how we start this thing. And I'm looking for 2 numbers that multiply to give negative 3 and add to give 5. And unfortunately, there are no such numbers here. So we're just going to write no solutions. are no zeros. At least not of the type that we can find in this manner, okay? So the next thing I'm going to do here is maybe try the next one here. Let's see what we get. Hopefully a little better luck on this one. And so I'll put 6 on the, oh, there's a common factor I forgot to take out. Okay, pull out 2. So that gives you 3x squared minus 16x plus 5. And when you multiply front and back here, you get 15. So I think we're going to get this star to work this time. 3 on the wings. And 15 up top, negative 16 down below here. 2 numbers that multiply to give the top and add to give the bottom are negative 1 and negative 15. So this side simplifies to 1 over negative 5. And we get down to this point here. 2 times 3x minus 1. That comes from here. And the other factor comes from here, 1x minus 5. So this is a bust. 2 equals 0. I don't think so. But this gives an answer of x equals 1/3. And this gives an answer of x equals 5. And there's another step to these. You have to give the x-intercepts. So it's 1/3 will make the y turn into 0. And over here, 5 will make the y turn into 0. And so the 2 x-intercepts are given there. 1/3, which is a little bit to the right of the origin on the graph, and 5, 0. 1/3, 0, and 5, 0. They're both to the right of the origin. And those are the zeros of the graph.